8.4 Logarithmic Functions. This is your introduction to log functions. Here's a definition of a log function. Let b and y be positive numbers. B is not equal to 1. The logarithm of y with base b is noted as this. Log base b of y. And is defined as this. Log base b of y is equal to x if and only if b to the x power equals y. So this statement works both ways. So we can write it like this in log form, or you can write it like this in exponential form. All right? They mean the same exact thing. All right? So that's what we're going to do first. We're going to take log functions. We're going to rewrite them in exponential form. So just remember the base of the log is the base of the exponent. What's on the other side of the equal sign is your exponent. And then what you're taking the log of is on the other side of the equal sign. All right, so let's see how this works. Here we go. We got the log base 2 of 32 equals 5. So again, 2 is your base for your exponent. The 5 is your exponent. And it's equal to 32. All right, now this statement has to be true. So 2 to the 5th power has to be equal to 32, and it is. All right. The next one, rewrite this one. Again, our base is 5. Our exponent is 0. And it's equal to 1. All right. And we know that 5 to the 0 power is equal to 1 because anything to the 0 power is 1. All right, the next one. Our base is 10. Our exponent is 1, and it's equal to 10. And that one should make sense. 10 to the first power equals 10. All right, the next one. Again, our base is 10. Our exponent is negative 1. And is equal to 0.1, which is 1/10, which is the same as 1 over 10, which is what 10 to the negative 1 would give us, is 1 over 10. All right, the next one. Our base is 1/2. Now, anytime you have fraction, you should put it in parentheses. Our exponent is negative 1. And it is equal to 2. All right, so a negative 1 on the outside just means we flip this fraction inside, so that would give us 2. So it should make sense that that is true. All right, next we have logs of the special ones. All right, these are the special logarithms. Okay, let b be a positive real number such b is not equal to 1. Then you have the logarithm of 1. All right, log of any base b of 1 will always be 0. Okay, doesn't matter what the base is. All right, you could have log 50 of 1, your answer could be 0. You could have log 100 of 1, the answer could be 0. You could have log 1/2 of 1, it's going to be 0. Anytime this is a 1, this other side is always going to be a 1 because remember when we rewrite it in exponential form, we're going to have this to the 0 power. And anytime, doesn't matter what that is, to the 0 power, it's always going to be 1. All right, as long as it's not 0. All right. And then log base b of b. Okay, so if we have log base b of b, all right, anytime the base and the number you're doing the log of, anytime these two are exactly the same, your answer is always going to be 1. Because remember, this is your exponent, or this is your base, this is the exponent, so it's going to get whatever this is to the first power is always going to be whatever that is. All right, so those are some special ones. All right, so again, log base b of 1, it's always going to be 0. Log, and whenever the base, and when we're doing the log of, whenever they're the same, it's always going to be 1. So those are two things you have to remember about logs. Okay, now let's see how these logs work. All right, evaluating log functions. Okay, so we're going to evaluate this. I'm going to show you how to do these using exponents. So what we're going to do is we're actually going to rewrite this in exponential form. So what we're going to do is we're going to set this equal to x. All right, then we're going to rewrite it. So our base is 3, our exponent is x, and it's equal to 81. All right, so what we have to do is we have to try to get the bases to be the same. So we got 3 to the x power, and now we just got to figure out, well, 3 to what power gives us 81? And again, you can just use calculator or any calculator. Got my graphing calculator, so clear that out. And if I just put in like 3 to the 5th power and I hit equals, I get 243. So then 3 to the 4th power, and that gives me 81. So now I know that 3 to the 4th power is 81. So we write it as 3 to the 4th power, and we've seen this before. Anytime the bases are the same, all we got to do is set the exponents equal to each other, and this, we get our answer. X is equal to 4, or log base 3 of 81 is 4. So 4 would be our answer for that. All right, the next one, log base 5 of 0.04. Okay, so again, we'll make this equals x. All right, and rewrite it. So I got 5 to the x power equals 0.04. All right. Well, I can't do anything with 5 to the x power, so we'll just keep that. This is 4/100ths, which is the same as 4 over 100, which if we reduce it, we get 1 over 25. All right, so now we got 5 to the x power equals, so we want to try to make this into a base of 5. Well, the 1 over 25, we can change that to 1 over 25 is 5 squared. Now, if I want to move this to the top, I'll be moving it to the wrong place of the fraction, so I just have to make the exponent negative. So I would make this 5 to the negative 2. All right, now our bases are the same. Since the bases are the same, just set the exponents equal to each other, and we get x equals negative 2. So the log base 5 of 0.04 is equal to negative 2. All right. Next one, we have the log base 1/2 of 8. All right, so again, we'll make it equals x. We are going to put 1/2, our base, to the x power equals 8. All right, now this one you got to do a little work to both sides, really. All right, so I'm going to do a little work to this side because I can see that this one and this one, I can make it both into a base of 2. This one I can make it into a base of 2 by moving the 2 to the top, all right, which means I'm going to put it in the wrong place. So I would make this 2 to the negative 1 to the x. And then 8, I can make that into a power of 2. 8 is 2 to the 3rd power. All right, now power to a power, multiply. So I get 2 to the negative 1x power equals 2 to the 3rd power. And now our bases are the same, so now we can set the exponent equal to each other. So negative 1x equals 3. I divide by negative 1, and I get x equals negative 3. All right, so the log base 1/2 of 8 is actually equal to negative 3. All right. Last one on here. All right, so now we got the log base 9 of 3 equals x. So now I have the base is 9 to the x power equals 3. Well, again, I want to look at both of these and I want to say, well, okay, I can write 9 as a base of 3. And this one's already a base of 3. So this time I'm going to change this side. I'm going to make this 9 a 3 squared to the x power equals 3, or 3 to the 1st. Power to a power, multiply. So I get 3 to the 2x equals 3 to the 1st. And now, again, I have bases the same. So all I got to do is set the exponents equal to each other. So 2x equals 1, divide by 2, and I get x equals 1/2. So the log base 9 of 3 is equal to 1/2. Okay, so that's how you can evaluate these without really using a calculator. All right. Next set of notes, we'll get in how to do it with the calculator. But for right now, just that's how you want you to evaluate these and the ones on the homework for tonight. All right, here we go. The logarithm of base 10 is called log. Anytime you see the word log written by itself, all right, log, well, it usually looks like this, but either way, anytime you see that word log written by itself with nothing else beside it, that means it is log base 10. Okay? So anytime you see that word log written by itself, that is log base 10. That is also, it's called the common log. Okay? Okay, so it's called the common log. So that's the one that's used most often. All right? Again, log base 10, which is written like this, log. All right, that is called the common log. All right, next we have logarithm. Actually, we wanted to say that this is also the number in this is in your calculators too. That log button in the calculator, that's what this means. It means log base 10. So the log button in the calculator, that means log base 10. All right, they hardly ever write log base 10. You saw it on the other side, but that's very rare. They just write the word log when they're doing it. All right, the next one you have to know, all right, is the logarithm with base e. All right, logarithm with base e. E is actually a number like pi. Okay, it is called the natural log. All right, natural log. And you might see it written as log base e, but it's very rare for you to see it as log base re. More often, you're going to see it denoted by this, ln. All right, ln. All right, log natural. All right, so that is the natural log. Again, that is log base e. You need to use this later on. But again, you won't see it really written log base e. You'll see it as ln. All right. In fact, in your calculator, it is ln. All right. So those are the two buttons in our calculator. I'm going to show you those right now. Okay. So how to evaluate common and natural logs. Now, this only works for common and for natural logs. All right. So log 5 in our calculator. If I'm doing that, what I want to do is this. Put it in the calculator, all right? And then I do log. Log button's right here on this calculator, okay? So if I do log and then 5, now I can close the parentheses if I want. I don't have to, and then hit enter, and that's what log base 5 is. So it's 0.698970043. Usually I'll give you what to round it to if I want you to round that to anything. All right, I'll tell you round it off to the nearest hundredth, thousandths, whatever. All right, but that's what's displayed. Now, just so you guys understand what this means. All right, this means that 5 to this power is going to give us 10. All right, so I can show you that in the calculator too by doing 5 to the, and then I do shift and answer, and you'll see 5 to that decimal. Something went wrong there. I don't know what happened there. Let me just check my mode. Oh, that's why. I'm in degree mode. I mean, I was in radian mode. Let me try it again. I think that makes a difference. All right. Let's go back. Clear that out. Again, we're going to do log 5, enter, and then I'm going to do 5 to the answer. I don't know why it's doing that. Let's try 5 to the 0.6989700043. That should be giving me a 10 because it's log base 10. Oh, it's 10 is the base. That's right. So 10 to that power should give me 5. I wasn't even thinking about how I rewrote this. So again, this is what I'm doing wrong. So it's 10 to that power equals 5. That's what I'm doing wrong. Okay. So clear this out. All right. So again, I'll put it in the calculator again. All right. So log 5, enter, and now I do 10 to that power is going to give me 5. All right, answer, and there it is. 10 to that power equals 5. So that's what it means. That's the power of 10. It's going to give me 5. All right. So then the second one, so that's the log key in the calculator. So now we got the natural log key in the calculator. All right, so now if I do the natural log of 0.1, I'll clear this out. Natural log is right here. It's right below the log button. It's ln. All right, so if I do ln of 0.1, and I hit enter. All right, so now what this means is that e to that power is going to give me 0.1. All right, so my answer here is negative 2.30258593. All right, now, so I'm going to do e to that power. So to get the e button, I do the second and the division key. So e to the, and then answer. So again, second, answer, and that is going to give me 0.1. And there it is. All right, so that's what you do. But those are the buttons in the calculator for log and natural log. Now, they don't work with any other bases. They only work with base 10. And that's it for the notes. The homework assignment is right here. All right, you got this 8.4 Practice C worksheet. All right, and I want you to do all of it. You can use the graphing calculator to graph this model if you want. I don't need to see it. Just for 30, you can do it in the graphing calculator. I just want you really to use 30 to answer 31, which should help you. All right, so that's your homework, and that's it for today.